Hello everyone. Today I've got a bit of a different video for you all because I have been working on a project a bit different from my usuals. I mean, usually I work on video games. This time I actually made an emulator. I got commissioned by some anonymous person to emulate apparently like a graphic calculator that was made in the USA like in the 80s or 90s. And basically you, instead of just putting in like cosine functions, you actually had to program the functions yourself using like a very basic arithmetic kind of programming language, which I found really interesting. I like Zaclax, and I also found the money they offered quite interesting. But anyhow, this is the result. I made the Shure OS emulator, and you can see it's a square. You can change the window scale. It's actually made in GameMaker just because that's the one that I was most used to. It was quite interesting to like decipher the actual code in the calculator itself. I saved them in so-called .semu files. So at the moment I've only got the calculator itself, obviously. And I'll just go ahead and run it now. It's called HI216. I really like those animations. I don't know why they put in the effort to add all of these in, but I really appreciate it. It adds a lot of character to this seemingly like utility object thing. So anyway, yeah, for the controls, it actually only has six controls, 4 directional keys, back and select. So I'll just I mapped them to the arrow keys, space and escape, respectively. So this is the main menu here. You have the graphs, which is kind of like the tutorial on how to use the program. Then these, I believe, yeah, these are the extra graphs, which only open up once you complete all of the graphs. And this is the sandbox mode, which is the one that's supposed to be mainly used once you have become acquainted with the program. And settings about it exist, so yeah, I really like these animations, they're really cool. So in the settings we've got brightness, I even emulated that. Volume, even unplugs the speaker here. I love this. Languages, I mean, in the original, like, I believe there was just English and then maybe some other languages for European distributions. So I just included the languages in a lang file here. So obviously I only added my typical 3 languages, which are the original English, Tikirchne, and badly translated English. Yeah, but I'll just use English for now. So anyway, I'll just go ahead and show you what the actual program looks like. So when you go to the graphs, there's actually 36 different graphs in 6 different categories. That's a lot of different graphs. And I've actually gone ahead and practiced some of these myself. So what you do is you go to the folder graphs, and here you have 36 different folders for the different graphs, and for each one you have different solutions. So if I just go ahead and into here, you can view the description. Obviously I've beaten this one already. So we've got graph number 1, out with the function y equals x. And what it looks like, you have to open up in an external text editor. This is literally the first level, really simple. Yeah, basically this means set the variable y to the value of the variable x, and then we run it, and it works. And here you can also see your previous statistics. But then they get quite a bit more interesting. For example, you have oh, this one was really cool, the square root, because obviously you don't have powers, you don't have exponentiation. This is number 15. Okay. So there we go. This isn't actually Newton's method. It's just like someone of method that I just came up with recently. I really love how how this code looks like. If you're not acquainted with it, it just looks like complete jargon. Like, no one knows what's going on. But it makes a lot of sense, and it's really cool to use. So as you can see, obviously it's the square root, and what I do here is I set y to be equal to 4, because as you can see, you even have like a trace option here, or you can see the different values for the preview. If you go to x63, yeah, so the maximum x is 63. After that it goes down to 0. So that's why I pick the middle. I create a variable called x2, set it equal to y and multiply it by y, so it's basically y squared. It should be y2. I don't know why I called it x2. And then I make a difference variable. And then while y squared is greater than x, because I'm trying to find the square root, obviously. While it's greater than x, that means that I have to decrease y. So I multiply the difference by a half, and I subtract the difference from y, and then I recalculate y squared. And then the same if it's smaller than x, except I add the difference instead. So then I basically let's say x is equal to 3, so I start out at 4. 4 squared equals 16, that's too much, so I subtract half, so I get 2. 2 squared is 4, that's too much, so I subtract a half of that, so I get 1. 1 squared is 1, so that's too little, so then I get 1.5. 1.5 squared is 9/4, which is 2.25, that's also too little, so I add a half of the difference again, so I get 1.75, and so on. So it's a really cool system, and surprisingly it actually works. I get yeah, this is the solution I used. And yeah, you also have these 3 metrics here, surprisingly similar to a Zacklink. So you have the size, which is the amount of commands, speed, which is the average number of ticks spent, and accuracy, which is how close it is to the expected values, which are inbuilt kind of to the program itself. So yeah, that's pretty much the program. I also, just because I love doing this, and also because I believe there were alternative versions, I implemented palette support, and you can even edit these yourself. If you go to palettes.png and palettes.txt, you can create new ones. I just love making custom palettes, honestly. This is a nice one. So you can just have fun with these. So yeah, I made the palettes. Also here you can create grid lines if you're into that kind of thing. You can obviously change the window scale, as I mentioned before. And yeah, that's pretty much it when it comes to the emulator. It's pretty simple, although it did offer quite a few interesting challenges when making it. For example, I discovered some code that was presumably some kind of old internet connection code or something, and I learned how to use HTML triggers, and I asked my commissioner about this, and they said they sent me which server to link to. So that was interesting to make, and it was also interesting to make it 60 FPS. And to load all the sprites and all of that from just one single file. Yeah, I don't know what the internet connection was for. Honestly, it seems like an online thing, but yeah, there you go. So yeah, that's the project I've been making. You can check it out using the link in the description. Although I make all of my links easy to remember. So this is the website 890.itch.io/hi-216. Yeah, I've also included the manual, a scan of the original user manual, so you can read up on how exactly to use the programming language, which is exactly what I used to make that square root function. And also, interestingly, I was sent this music album. It's Minnesota's Technical Revelations. You might recognize it from my old game, The Six-Sided Computer. I actually used that album as well, except this one has a bit different titles. So for example, digital is renamed to digital environment, and loading is loading graphs. It's a bit of a different order as well. TateOS and Hexbox are productive ambience, Vol 1 and Vol 2, Volume 1 and Volume 2. Yeah. So anyway, that's my newest project. If you're interested, I highly recommend that you check this out. This graphic calculator, I mean, obviously, like, it's not a game. Like, it's not meant to not necessarily meant to be entertaining, although it is quite entertaining to just play around, code the different functions. So yeah, there you go.